It must be 6 o'clock in the evening here in England. So welcome to our 16th. I always got to try and remember. Welcome to our 16th Open Clock Club. I think there's been some kind of software update on my computer because we seem to have a wider field of view for our camera. So gosh, how exciting can life get? Anyway, hope you've had a great week. I'm not going to waffle on too much this week before we get started. We're going to kind of jump into it reasonably quickly. As always, remember this session is recorded and it'll go on our archive YouTube channel. So if you want to remain anonymous, then please keep your camera turned off. The engine room of this event is the live chat. So as always, please keep the live chat going. We find it fascinating. It's great to see all those questions, and we print the thing every week and get a lot of inspiration from it. So thank you. So we're Team Open Clock Club will keep that going. Super special welcome to new people this week. This, remember, is ostensibly for beginners, although we tend to go off on tangents and you ask questions, which is fantastic. And extra special welcome to those people who have bought our book this week. So very quick update on the book. We tried very hard, much pulling out of hair, as you can tell, and failed on shipping books to the States. So we've got some leads on a printer in the States, but obviously that's going to take some time, so apologies for that. Oh, and we sent our first book to Australia, so yay, thank you, whoever it was in Australia that bought the book. So we're going to press on with our pallet refacing this week. We've got a bit of preparation done. And remember that if you want more how to repair pendulum clocks, you can join us on Thursday night for our live stream. We had a bit of a clash last week, which was unfortunate with the Antiquarian Horological Society. So both the AHS and our thing recorded, and you can see them later. And our Facebook group has been really on fire this week. We've covered all sorts of cool stuff about repairing clocks, about tools, and that kind of thing. So we've been helping one another, and I'm really delighted that it's a super supportive environment. So thank you, everybody. You know who you are, who have been contributing to the Facebook group feedback. So let's get rid of that and let's put this in its place. Our clock that we're going to be refacing the pallets on. And I'm going to just quickly go back to a drawing that some of you have seen several times. So here it is. But it's worth, I'm not going to draw it again, I've already done it. But it's worth just recapping what we're doing here. And let's just look at our drawing. Here we are. Here's our lovely pallets, theoretical pallets. And we've got our theoretical escape wheel tooth here. We only really need to think about one escape wheel tooth at any one time. That pushes the pallets, which rotate anti-clockwise here on the entry pallet. And then when this pallet gets to this point, then this escape wheel tooth gets to this point on the pallet, sorry, it drops off and lands on here. That's our one theoretical tooth. Same thing here, when this escape wheel tooth gets to this point, it drops off and it goes all the way around and effectively lands on here. So when these components wear, either the pallet face and or the escape wheel teeth, eventually this value and this value here increase, drop, which as we've talked about plenty of times before, that's lost energy. It's the train, the weight, the spring, whatever, everything's moving but not doing anything. It's not doing any work. So we want to, within reason, without getting obsessed about it, reduce that drop. And one way we can reduce the drop is not by polishing wear out of the pallets in the first place. However, the problem is we often find clocks where people have already polished out wear. And I think personally that's a kind of a problem, but we'll deal with that at the end when it comes to the kind of conclusion. So in order to reduce either internal or let me just move that out of the way, or external drop here, we can do one of two things. We can either add material here on the pallet face or add material here, or we can add length here and we can add length here. That does it does effectively the same thing. Now, I will admit, of course, if you add length here, then you're changing very slightly the geometry of the pallets. So what we've done on the pallets we're going to look at, they've already been refaced here, so we're just going to leave that alone for the time being. We're going to add some material here, some thickness, which is going to reduce external drop. And what we're going to do is we're going to leave this material over length, so there's probably no internal drop, and then we're going to cut it back until it just ticks like that. So this is, sorry to repeat things, but we've got new people this week. So do this drawing. If you want to get your head around drop and the escapement, do this drawing. Now, I'm sure what John would say and what I would say is that there's a lot of kind of unnecessary work carried out on pallets like this, when frankly, well, I don't know, if you go to the Facebook group, I've refaced some pallets this week and got the drops right down, and the clock is banging away, as you probably heard a few minutes ago. Anyway, so this is what we're going to work on here. We're going to work on adding material onto that entry pallet, which will decrease external drop, and then we'll cut back here to generate some internal drop. So let's have a wee look at our clock. You can see in here, a little bit difficult to see, but if we just get the thing ticking, so we've got the third wheel in, then the escape wheel. Now you can see there's a little bit of a delay. If you can just see it under there, the active escape wheel tooth. Remember, I'm really conceptually thinking about one escape wheel tooth only on this clock. That is now on our exit pallet, and as the crutch moves away from the camera, you see that we've got what might be described by some people as a lot of external drop, and that's what we're going to reduce because that's lost energy. Now our active tooth is resting on the exit pallet, entry pallet, sorry, and it's pushing the pallets in a kind of clockwise direction here. You can see the active tooth is moving towards the end of the exit entry pallet, and it's now dropped onto the exit pallet and vice versa. And you can see here, look, there's a lot more external drop there, you just saw it, than there is internal drop. Okay, so kind of the answer here is, before you dive into this work, figure this thing out, the kind of relationship between the two. And it takes some getting your head around. Now, as always, I normally say we would wear gloves, and we've done a whole video on them when handling any historic object. I don't here, but just because we're trying to get a kind of move on and so on. So let's just put our clock to one side for the time being. Oh yeah, just before I go into that, the good thing about this back cock, if we just look here, see it's been rebushed there for some reason, and it's got no steady pins. Now the clock I worked on during the week had steady pins, so you're stuck there with that center distance. This has got round holes, so you sometimes see these holes have been overlised, or like on the Smith's Enfield mantle clock, the holes are overlised from new. Now, if you feel tempted to file those holes oval, something is pretty drastically wrong. Now, the screws here are a reasonably good fit in the holes, like that. So, but there is nevertheless a little bit of movement. So that's just going to buy us a bit of wriggle room when it comes to external drop. On that, maybe if you watch this thing back later, on that arrangement of escapement where you've got one effectively horizontal pallet face and one effectively vertical pallet face, changing the center distance, the distance between the escape wheel and the pallets, radically alters external drop, but it doesn't do a whole lot for internal drop. And whereas on the Smith's Enfield clock, because the pallets are at different angles, it actually adjusts both when you change the center distance. So anyway, we've got a bit of wriggle room there. Here's our pallet frame, and I've got my pointy stick somewhere. Always lose my pointy stick. Anyway, one pallet, the exit pallet here, has already been refaced, and you can see it's been running an amount of time on there. There's a little sort of witness mark, but the entry pallet here hasn't. It looks shiny because it had some material on it which I took off for this demonstration. In fact, under there, you can just see in the light some wear mark from the original pallet face. So it's a bit of a shame if this is actually being cut back to polish out wear or something, but you know, who knows? We don't know what's going to happen there. So what we're going to do is we're going to take a bit of material. This, we talked, not last week, but the week before, about what kind of material you might use here. I'm using the kind of the traditional way of doing it in this instance, which is blued steel mainspring. Now, lots of people, and I'm not at all against it, just stick the mainspring on as it is. The problem for me with that is you don't know how hard that material is. So what I'm going to do today, and it may seem like a bit of a faff, is to put the metal on in its annealed state. Last week or the week before, I can't remember, we annealed the material by heating it to red or orange, in fact, and allowing it to cool slowly. And that's great, particularly for the beginner, because on this entry pallet here, we can see the pallet face now, whether it was when it was new, who knows, is flat. So we want a bit of flat material. And of course, if you're using a bit of mainspring, that isn't flat. So you've got to try and flatten it out somehow. The other material for those people who've just joined us is that we looked at using gauge plates, so ground flat stock, which is a modern ground tool steel, which is also good because it's new and it's plentiful and it hardens really well. So last week we cut our bit of steel. Once we'd annealed it, we cut it down to about 0.2 of a millimeter too wide. Now, if you just look on this one, if you can see it there, but the bit of material that's been put on here, yeah, you can see it there more, is wider than the pallet frame. And I really like that. I'm perfectly happy to leave the material 0.1, 0.2, whatever this is, 0.3, 0.4 of a millimeter even wider than the pallet frame, because if you do that, you don't have to refinish down onto the face of the pallets, and I don't want to do that. So I'm happy with that thing. Some people wouldn't like it, but there you go. So we've left our material a little bit too wide, although I've actually cut it a bit too narrow, so it's probably going to cause me a problem. So we're going to do two things now. We're going to tin that, supply a layer of soft solder to both those faces, and we're going to then solder them together. So I've cleaned up although I've been touching it with my greasy fingers, I've cleaned up the surface of the metal here with an oil stone. We talked a bit about stones last week, and that's what I'm going to do first. I'm going to keep everything crossed and tin this. Now, the secret to relatively successful soft soldering is to use a spirit lamp, in my view. If you use one of those little gas torches or a big gas torch, it's so easy for the thing to overheat. Then all that happens is the work goes black and then nothing sticks to anything, and it's all a mess. So I'm a big fan, as you probably gathered, of the spirit lamp. So first thing we'll do is light that up. I've already set fire to my jacket once today, so you might be able to see down here. So that keeps things exciting. And I'm just using regular Barry flux, which is, as it says, it even says regular on it. So regular flux paste. Remember, when you're doing this in real life, to make sure that the flux is totally washed off everything. Otherwise, it can be corrosive. You don't want it on your fingers, you don't want it on the clock. So what you won't see here tonight is getting lots of soapy water on the thing afterwards to make sure the flux is thoroughly washed away. And then I'm using, I've lost the label, but this is just regular low melting point soft solder. First thing I'm going to do is I'm going to take a bit of steel wool. This is 4/0 steel wool, so the finest grade. I've got to keep it away from my lamp there because steel wool is quite flammable, and we have both, John and I have both got horror stories of using steel wool and nearly setting fire to something. So with your used steel wool in particular, keep it in a sealed container, especially if it's got any oil on it, because it is really easy to start a fire. If you go on YouTube, it's kind of a popular thing to set fire to steel wool and then whiz it around on the end of a bit of string. So I'm going to, if we were to put our solder here straight onto the pallet face like this, then it's quite difficult to control how much you get on there. It's easy to end up with an enormous blob, which kind of doesn't matter, but it looks a bit ugly. And we've all seen soft soldered work with an enormous blob of solder on it. So what I'm going to do is I'm going to take my, just cut that end bit off. I'm going to take my scalpel here and I'm going to just cut some small pieces. So if you've ever done silversmithing, this is not aligning myself to a silversmith, by the way, but this is how the silversmiths might do it. They cut the solder into small pieces because it gives you control. Now, if you, I'm putting it inside a bag, because what happens is when you cut the solder, of course, it flies off somewhere and you can never find it. So top tip number one, if you actually cut it up inside the bag, the bits don't fly away. So there you go, top tip. So let's get one of those little puppies and we will apply flux to our pallet face. So there's our bit of solder. And we're going to need a little bit of brass wire to, let's just put that under there. Need a little bit of brass wire to spread the solder out with. As I said, the key to this is to make sure that everything's fluxed, that everything's clean. Remember the golden rule, I think there are 3 rules of soldering, aren't there? Can't quite remember what they are. Oh, the first rule of soldering, according to Reed, is cleanliness. And according to everybody, if the work isn't clean, you won't solder. And I think this is often the case with brazing and all sorts of stuff. The second thing is the solder has to have somewhere to go. So if you've got bigger components and they're really tight together like that, the solder can't get into the joint. And the third thing is you've got to have the right temperature. So if you put the solder on before it's hot enough, then it'll just sit there going black. And if you get the thing too hot, then everything will go black and it'll never solder. So I'm trying to, as you can tell, I'm putting off trying to do the job. Yeah.
Get the spirit into the actual lamp, the liquid.
How do you get the spirit into the lamp? The top screws off. When I was teaching many years ago, we always had those glass-bodied spirit lamps, and like they would last 2 days because you got 10 people all using the workshop. No disrespect to the people who are using it. It was just a fact that the spirit lamp would always get broken, and or the top would be missing, so the stuff had evaporated. And then I discovered these metal spirit lamps. It's like a kind of no-brainer, really. So just a bit of steel wool here to make sure that that just move that pallet face is clean. We talked a couple of weeks ago again about the heat sink for this collet. I'm not going to put the heat sink on this week. I will risk it for the sake of this demonstration that the collet isn't going to desolder, but it, if you were doing this on a real clock, as it were, then you would definitely want to put something there. So I'm just going to put a little bit of flux on, comme ça. and put on our bit of solder, which might be a bit small, I don't know. We'll see how far that goes, and then hopefully without again setting fire to my jacket. Bit more flux on there, which is probably too much. I think the solder has got flux inside it anyway. It's cord solder, so we're just going to take our time here and heat up the solder. This is really nerve-wracking because it's bound to go wrong. Got to be patient.
Jonathan, shouldn't you do the other pallet first?
There we are. Good. So John says, shouldn't we do the other pallet with me? Solder it.
Yeah.
It's already done. The exit pallet has been finished by somebody else in a different life of the clock. So I'm happy with that. I don't need to redo it. So I'm just doing this one for the demo. But it's a good point. If you were decided, going back to the drawing without labeling it, you've got decisions there. You can either do both pallets. I often only do one on the clock that I've just done this week. I only needed to do one, and people might go, oh, why would you want to do that? Because it didn't need any more, and I didn't want to remove any material. I didn't file back or polish out the wear at all. So you've got a decision to make as whether to do both or one or neither, of course. Anyway, that was incredibly successful, if I do say so myself. The pallet now is covered in a layer of soft solder. That's what they call tinning. Now we're going to do exactly the same thing. When you're soft soldering, you tin both surfaces. So same thing again. I'm going to clean the bit of metal that we've got. Yeah, I'm just going to put some flux on here. As you can see, I've left the metal really long, so I can hold on to it, and I'll just cut it when it's actually soldered on, which in this first phase of before we harden the metal just makes it a lot easier than with your tweezers there and the bit of metal going on the floor 10 times, which is kind of normal. So again, we just pop our little bit of solder on there. Now this is going to be much quicker because there's much less material mass there. We haven't got the pallet to heat up first. So we've got to be super careful that it doesn't get too hot. I'm going to hold it in a pair of pliers, but please bear in mind my point about everything going rusty. In the old days, there used to be that flux called baker's soldering fluid, which I think is like the devil's work nowadays. It was great for soldering, but everything within a 100-mile radius went rusty when you used it. Can't remember what the chemical was in that. Somebody in the live chat, let me know what the chemical was in baker's soldering fluid. So any questions in the live chat before we go into, yeah?
Why not use a soldering iron?
That's a good point. Yeah, use a soldering iron. I've always found that with this, you probably could. Or in the old days when you used to have the soldering irons that you heated up in a big copper bit. Yeah, I think you could. I think that would be a really good idea. I think for this part of it, the electric soldering iron would be fine. I don't have that much experience of those other than acres of frustration when I was young of never being able to get things to solder. But yeah, a powerful soldering iron no doubt would do the trick. I would try it, and that would be again more controlled and the thing not going black. So I'm just going to heat. Oh, the light's setting on fire. There we are. So amazing. 2 things have gone right tonight. So whatever else happens, it's been successful. Brilliant. Gosh, is that the time? It's nearly time to finish. Good. So that's, if you get to that stage and both bits of material are neatly tinned without going black, then give yourself a massive pat on the back, because that is actually takes a bit of practice. He says, it sounds self-congratulatory, but I was very nervous about that going really wrong. So back to our soldering the thing together. So I'm just going to join them together now, because if you've not soldered before, because both bits have got a layer of solder on them, when you put them together and reheat them, they just stick together. It's a really critical point of soft soldering. So slightly awkward here. Now I know that, because I had a look under the eyeglass, you'll remember that the internal drop here is, just turn that light down a little bit. The internal drop is not crazy. So what I don't want to do is leave the metal so long when it's hard that I spend ages either stoning down or using a diamond file to reduce that. Now it's going to be quite tricky to get that exactly in the right place. But the beauty of the soft solder, again, you don't want to keep reheating it, is that it gives you a bit of flexibility if it's not positioned right in the first place to reheat. And this seems like a faff. It's a process, as you probably gather, that I haven't particularly enjoyed. And then I thought, well, it doesn't really matter, because you're going to do this and it's going to be fine for decades, absolutely decades. Now, ideally, I'd be working the other way around here because I'm right-handed, so this is going to be a bit awkward. But I'm going to actually just tack it on, unless it gets too hot. Yeah, gets too hot. There we are. So I maybe didn't see that, but you saw the solder melt. Yeah, just saw it squidge out at the side. So again, I'll have to be, for the first time in my life, I'll be patient to allow it to cool. Otherwise, it'll just drop straight off again. Again, if I'd have got organized, I'd have a bit of wet cloth or something here that I could just cool it down a little bit. Right, good. Right. Okay, so far so good. So just have a bit of a tidy up. Yeah, question. Yeah.
Got a pendulum bob that's slightly wobbling on a clock.
Yeah.
Seems to run for days and once a while suddenly stop.
Right, okay.
Is this something to do with why the clock might stop? What to watch the check for? Yeah.
Okay, so a nice little break. In fact, it's past, so we're going to have a comfort break in a minute. We'll probably just have one this week, so we want to get this done because it's dragged on too long. So question from live chat, brilliant question, and it's a major, in the next few months, I'm going to do a top 10 things that are the death of your sort of clockmaking business, and one of them is the pendulum not swinging cleanly in a plane. And 9 times out of 10, that's to do with the suspension spring that the pendulum can't assume. I don't think it's anything to do with the escapement per se. That isn't where I would look. But absolutely, if the pendulum bob is swinging not in a plane, if it's kind of oscillating or weaving, that oscillation can build up to the point that absolutely it stops the clock. And so the first thing is, can the pendulum assume a vertical position? Often on a long case clock, the top block of the suspension is square, sitting in a square hole, and is bonkers because it can never, well, the chance of it hanging vertically is incredibly slim. So the top block of the suspension wants to be curved. Again, if you go back on if you look on the Facebook group this week, I made one with a little round thing on the top. So the suspension hangs straight. The second thing to look at is that the crutch, if you imagine the crutch on a long case clock is parallel, it should be reasonably parallel, but don't go filing anything off. Often the crutch isn't aligned with the top block of the suspension. They're like this a little bit. So ignore what the clock frame looks like because the backcock slot, so this, where are we? This thing here is often cut by hand. And in fact, you can just about see here that it's not square with the backcock. Doesn't matter, nobody cares about that. Don't be fussed. This is a great example actually of that. You can see the slot isn't square with the backcock. So the pendulum is not going to swing parallel with the movement frame. It doesn't matter. It'll be slightly off in relation to the backboard of the case, but who cares? What is important here is that the crutch, like this, and that slot are aligned. The crutch doesn't need to be aligned with the back plate of the movement. If these two things aren't aligned, what happens is, if they're like that, exaggerated, is that the pendulum only gets an impulse at one side of the block and it causes it to wobble. So there's the two things. First thing, check the suspension spring and everything can hang vertically. Second thing is to make sure that the backcock slot and the crutch are aligned. And the third thing is when you put your top block of your pendulum in here, then make sure that there's a bit of oil on both sides so that it makes this kind of viscous coupling, if you like, using the term slightly loosely. Right, we're going to break now just for a quick comfort break. I can't quite see what time it is. It's 31, so let's come back. It's nearly 32. So let's come back in a couple of minutes at 34 and we will get on with these pallets. Wobbling. Okay, welcome back. Little break there. So there's just a question about recapping on the crutch and the suspension spring. I won't do it right now because this refacing thing has gone on too long. So I'll press on with this for now, if you don't mind, but we'll either come back to it on Facebook during the week or we can make it part of next week when we do our re-pivoting. But basically, make sure that the top block of the suspension spring and the crutch are in line. Okay, right. So what we've achieved now then, we took out a bit of mainspring, we annealed it to soften it, we flattened it out, I stoned one side. You've seen this evening, we put soft solder on one side, we put soft solder on the pallets. That process is called tinning. And now we've fixed them together like this. You can see I've left it about to length here. But what I've done, look, at this end, I've left 1/2 mil. So I can actually slide the bit of metal along a bit, and we can remove this later with a diamond file if needs be. So bearing in mind what I said before, that I would normally take this away and give it a really good wash in hot soapy water to get the flux off. And thank you, Fry's and Baker's, I think, are zinc chloride. Don't go near that stuff as much as it's brilliant. So we're going to try this back in the frame. If we're happy with our drops, then you can see that this is much easier to adjust now with the metal being soft than it would be if you were trying to do it with a bit of hardened spring. That's why I go through this rather convoluted process. So very quickly, let's just pop this back in here. Okay. Screws. We go. Get that. The deck, sound effects. So now we make our adjustments, and ideally, like if you make a clock, what you want to do at this point is to get the escapement ideally so it just doesn't run. If we were, as I think it was John that said, if we were refacing both pallets now, what I want to do is to get it so they're just jamming right on the corner. At this point, you don't want it to work, which seems a bit crazy. You do that final fixing by stoning or with a diamond file later on. Yeah, I like making pallets. And that reminds me, actually, we have a lot of correspondence during the week about people who are obviously really creative and they want to do this and they want to do that. And I would say the answer is make new clocks. Let's start another group about making new clocks at some point. So, okay, so let's have a look here.
John says, is it worth mentioning the problem of fingerprinting with flux?
Yeah, definitely. I mean, that's why normally with fingerprinting with flux, normally I totally wouldn't do it like this. I'd be wearing my gloves and I would wash everything. And then, of course, immediately after, you have to wash anything that's come into contact with the flux. Otherwise, you're going to run into problems with fingerprinting. Now, I noticed before, if you can see there, look, this escape wheel has been recolleted at some time and it's still not perfectly concentric. I'm not bothered about that. But what we have to bear in mind is we can't take the drops down maybe as much as we normally would, because what's going to happen is it'll hang up on 1 or 2 teeth. And as it is, right there, do you see that? It was, let's just go back. So the drops look really good, but there it's jamming. There's not enough internal drop, sorry. Frame's really wobbly. There's not enough internal drop, which is perfect. So that tells us that the length of that entry pallet addition that we put on there is about perfect, because once it's hardened and fixed back on again, what we can do is we can just stone it back and that'll release that tooth. Or we can say for all the other teeth, it's absolutely fine. We need to look at that one tooth. And of course, drop is always a relationship between 2 teeth. So either one is longer or shorter or further round something. So it's a relationship between 2 teeth. So let's be thinking about that. If we've only got 1 rogue tooth, do we increase drop for all the teeth, or do we deal with that one rogue tooth by bending it back or something like that? So really happy with this. Let's be really cool if we could get this done. So just before I came on, I was looking at George Daniels' book again, because it's George that says in his book, Watchmaking, you can stop fire stain with soap, just like a regular kind of hand soap thing. And I've never found it works at all, but we're going to try it again. So the first thing is, we want to now get this off. We're happy with this. It needs polishing up, but we know that the length is within tiny amount. So we're going to get this off here, and we're going to harden it dead hard, and then we're not going to temper it back again. I'm going to leave it on dead hard. Okay, so back here. Now this whole project seems like a bit of a faff, but I guess if you get practiced at it, you know, it's going to take 20 minutes per side to do the pallets, you know, and given that that's going to last decades, I don't think that's too bad. Right, I do not want to lose this on the floor now. So you can just see the steel turning color. Do you see that? That's a really good indication. So you could just see the steel going pale straw, dark straw. I was going quite quickly. So that's a nice indication that you're at the temperature where the solder melts. Okay, so the next stage is to harden this dead hard. So we're going to heat to red or orange. We're going to quench in cold water. Now, to hold the thing, our precious little bit of metal, I've going to use some iron binding wire. Here it is, really useful workshop material. This is a kilo of iron binding wire. It's a bit thin, this stuff, but it's fine. And it's really great for holding things when you're soldering and that kind of stuff. Somebody's got a question up there, Rachel.
Yeah. Solder on the spring is no problem when you're hardening?
Good question. The solder on the spring when you're hardening. The only problem I've found with it is that it sometimes sticks to the wire. But no, surprisingly, well, we'll see. Many a great plan and all that stuff. But no, I just harden it with the solder on. Sometimes it gets round onto the other side, but we're going to stone that off anyway, so it doesn't matter. And Ian's got his hand up as well. So I've got a bit of material, and I'm going to make, I might not do it because I really want to get this done, a little holder. So just wrap it round like that, your binding wire to hold a bit of material. But here is one I made earlier. Again, all this is in Daniels. You don't need to buy our book, you need to buy Daniels and then make a watch. So I'm going to try it for the last time in my life, putting on soap to prevent fire stain. Fire stain really relates to soldering silver, and it's when it goes black and then you can't do anything with it. So there are proprietary materials and boric acid, I think people use. There's a material, there's a product called Argotect, which you buy from Cousins RHS Walsh, and I've never found any of them to work. So I'm going to use good old George Daniels method. No doubt George had posher soap than I've got, but anyway, there you go.
What gauge is the binding wire?
Ooh, good question. What gauge is the binding wire? I could do one of those nice wire gauge things. Yeah, Ian's got his hand up, Rachel. You... Oh, I see. Sorry, Ian, you've got your cat head. There you go, in metric, that's what it is. Somebody can convert it into standard wire gauge, all right? Ian, if you want to ask a question, you have to unmute yourself. So again, in the live chat, please, if you've used boric acid for this process, then successfully, then please let us know. That would be interesting.
What's that white stuff?
Soap, hand soap. That's the stuff we got before.
The interface just complex.
All right. Okay. Cool. 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 Somewhere I've got. Cold water, plain old water, like that. So we're going to heat to bright orange, and then we're going to plunge it immediately in water, and that bit of metal will be hot, hot, hot. Now you won't be able to see the water, unfortunately, because I can't get them both in the, or maybe I can. No, it's too much faff arranging the camera. Use our blowtorch now. Okay, so when you're hardening and you want it to be dead hard, take the flame with small components like that, take the flame to the water. You want the cooling to be absolutely as rapid as you can get. That little torch I've got in here is pretty underpowered. If you're going to, if you're setting up a workshop, buy the sievert system. I think it's the best system. I have got one somewhere, but not in here. Right, let's have a look. You'll notice that rather in a homemade way, I've got my health and safety labels on there. If you've got things in the workshop for might look like water, you don't want anybody drinking it. Right, as always, they. Oops. Right, okay. I lost it, thankfully. So there's our piece of material. And the, yeah, maybe if I'd left it in the, sorry, maybe if I left it in the soap, it would have been better. It's not brilliant, but it's all right. Anyway, so I'm going to have to clean off some of this black, and then we will solder it back on again. But now it should be, let's just get a file. Yeah, pretty dead hard is that, I think. Okay, it's got to determine which side is which. There for a sec. Right, okay. So again, to solder this back on, we have to clean the thing up again. That's why that process with, if somebody can get to the bottom of it, and I know on the NAWCC fora, there was a lot of questions about this, about anti-fire stain, because it's always a real faff cleaning up the material again. Now, hopefully with this, because that lead is on there, it's not going to be, not lead, soft solders on there, it's not going to be too bad. Maybe actually the solder has helped us out here. Just using a scalpel to scrape off the black stuff, which of course will have got rid of some of our solder. But yeah, there we go. If I can just pick it up like that. Quite clean, quite pleased with that. So all we have to do now in the next 10 minutes is resolder it onto the pallet face, and then we can clean it up, the black side with a ceramic stone, and then we can just make a decision. So what's the decision, people out there? If we've got one or two teeth that are causing a problem, do we deal with the teeth, or do we just leave those 200-year-old teeth alone and just give the whole thing a bit more drop? So we need a vote coming on. So you either type in the live chat teeth or drop. So I know which one John's going to go for. Teeth or drop, teeth or drop. Right. Now, because we've lost a bit of our solder by the scraping there, I'm going to actually just put a tiny weeny bit more. No, maybe not, actually. I think we'll be okay. Now, this only goes on one way round because I'd finished one end. Yeah, got that.
It's 3-all, teeth and drop.
Teeth and drop, 3-all, 3-all. We need a tiebreaker. Come on, somebody else needs to vote on teeth or drop. And I've lost my bit of wire.
Another drop.
Another drop. Right, okay. So it's we're going to look at dealing with those teeth then. Or does that mean we leave more drop? Who knows? Anyway, neither drop. Right, okay. So I just need my bit of wire again. This brass wire, by the way, is incredibly useful if you want to make an oiler. Just anneal one end, flatten it, bend the other end round into a little triangle, and you've got an oiler that will last you a lifetime. Here in this case, I just need a new spreading device. Clean that up. Normally what I'd do is just actually put a bit of solder on the little tool that you're going to spread with to kind of tin that first. And because we've been so lucky so far with our fluxing and soldering, we're just going to do that again. There we are. And now we'll just go back to our palette here. Yeah, I'm just applying a bit more flux to the little hardened palette face. Maybe it's a bit much. Excuse fingers. Right, okay, I'm gonna have a little look, check it's, yeah, on in the right place, give or take. Right, here goes nothing. Do you see the pallet move then, the little bit of steel as the solder begins to melt? Right, again, you just have to be uncharacteristically patient here. Yeah, question?
When the solder squidged out,
yeah,
does it need cleaning up or storing off later?
Yeah, just if there's excess solder, just get a scalpel, new scalpel blade and cut it off. Right. It says rather hopefully, I hope that's stuck on there. Let's get rid of that, get rid of that. And what we're going to do is just have a very quick look at this. We've got 5 minutes. Okay, so I've actually soldered it back on about 1/4 of a millimeter further out, so not further in, sorry, so there's less internal drop. Now we know last time that was right on the limit anyway. So what I can do, because I'd left a bit at the end, I can either leave it like that and stone or diamond stone it back. And because it's gone on nice and straight, I'm actually going to leave it knowing that there'll be too little internal drop, the escapement won't work at all, and we'll just use diamond files, because I've got new kind of diamond file things which are great, but making a video about them. So next thing to do is to clear up this face, which has got flux and stuff on it, fire stain. So for those of you who were here last week, taking our trusty 1000 grit ceramic stone, bit of water with a little bit of soap in it, just as a wetting agent. And I'm going to hopefully be able to stone this. Now, because I want to get this done today, remember, keep it nice and flat. And again, on my hobby horse of trying not to use abrasive paper, sorry, my hand's in the way, isn't it? But you can see I'm stoning it on the edge of the, we want this pallet face to be reasonably flat. Sorry, all you can see is my hand there, which isn't useful, but anyway. Now this is going to normally take 10 minutes, I imagine, so. Oh, surprisingly good. I'll show you in a minute. We've got, so just got a little patch in the middle there. Now I would normally take that off, but because we're running out of time, I might just leave it. Nearly gone. Okay. So let's just move to a finer stone. This is about 6000 grit, just to put a bit of a finer grind or a polish, as we might call it, on there. And again, just the same thing, keep it nice and flat. Now this material's dead hard. If you read about books about watchmaking and all that kind of stuff, you will realize that you can't really get material that shiny, polished, if it isn't hard. You can only get to a certain stage when the material's soft. So if you wanted, you could get this pallet face really shiny. I'm not sure there's much point past the stage, but yeah, you can see there, look. Quite nice. Just needs a little bit more on the edge, but we're going to lose that anyway. So, running out of time. let's just pop this in it. Now we know that this isn't going to work because it barely worked last time, but that's a good thing. Remember, if you do this and it already works, then you've got a bit of a problem. So let's just have a look at that internal drop. And apologies for people who have to go because time's up, but I'm just going to press on with this for sake of getting it finished. Then we don't have to return to it again next week. So remember, this slight bit of adjustment we've got on the back cork doesn't really help us with internal drop anyway. You can move the back cork up and down, so not particularly bothered about that. Right, okay. So there's our external drop. Did you see that? I'll just put it back on there again. If the wheel going the right way would help. There's our external drop, but of course, 0 internal drop. Now, if we look on the inside here, you probably can't see on the camera. Oh, you can actually, can just about see. The tooth is incredibly close to the end, which gives us an indication. Oh, pins are dropping out on the clock of how much material we have to remove. Okay, so I'm going to remove that. You could do it by stoning, but I'm going to use diamond files. This week I've got some, they're not exactly diamond files, they're diamond laps by the American company Easy Lap, and they're absolutely brilliant. I won't spoil the video I'm going to make. I've made the video, I just haven't edited it yet. But there is a bit of a drawback with them, and that is that they're on a kind of plastic substrate. So, which lets the whole thing down from a clockmaker's perspective. Let's just get them here. So apologies for running over. And as I said, some of you may have to go, but you can catch up on the recording. So we've got 3 of these Easy Lap diamond laps, and it's absolutely brilliant product, fits in the hand really well. But the problem is that it's on this incredibly squidgy, and you know I don't like squidgy, backing, which is really frustrating. Now, there's no criticism of the product because this company makes diamond things that are on metal backings as well, and diamond files. But this actual thing, which is really useful, what I want to do is to take this off and put it on a bit of brass or something. But anyway, that video will come out in a while. And the beauty is this is absolutely one of the best cases where you would use a diamond file. Now, a bit like the flux on the thing, this is a demonstration, remember, I'd be very mindful of diamond dust getting into the clock. So everything needs to be really washed after. But for keeping away from that original or early original surface, you can see there, let's just move around a little bit. And this is where I want this diamond file, if you call it, or hone or something, to be really stiff. I don't know if you can see on the film, but the plastic bends and it is annoying. I bought the wrong product, basically. Well, the good thing about diamond, of course, is it cuts incredibly quickly. And you can keep it reasonably square. It's not as good as it would be if it were on a stronger backing. Now, again, I'm moving on here. Really important point is that even though that's diamond, it's thrown up a burr. You might be able to see it, but you can certainly feel it. Now that is, because this is hardened steel, it's going to really cut your escape wheel badly. So the critical thing to do is to take a stone, which I may not be able to find. Where did that stone go?
Yeah, the box of stones.
I did have my box of stone. Oh, there they are. Take our little degusit stone that we talked about last week, which is crystalline aluminium oxide, ruby. Once you've done the diamond filing, just roll this round to very, very, very slightly deeper and radius that corner. So I'll just do that until it's gone. Otherwise, it's going to damage the escape wheel. I mean, you don't want that thing rounded as such, but you just want to make sure that tiny little radius there. I'm slightly paranoid about that, cutting the wheel, so make sure it's really smooth. Okay. Right, that's about halfway actually to where I know we need to be. So I'm going to do some more of this with this medium diamond. Sorry about all the wobbling. I'm just going to stick with this until it's done. Now, if this were new pallets, this is the complete moment of truth. Remember, if it was new pallets or you were refacing both sides, you will be working on both, and you will be thinking about that original drawing that we did of the external internal drop, how reducing this length is going to get those drops right down. And of course, the beauty of doing it this way is it's incredibly controlled. Even though it's diamond, it still cuts relatively slowly, I suppose. Let's try it. Might just need a bit more. The thing about this is you really get used to putting the pallet frame in the frame. Especially when doing it in front of a crowd of 40,000 people. Got my nice cheap screwdriver here, chrome-plated screwdriver. The so-called nice screwdriver didn't fit these slots, so I've moved over to this one, which was bought by my granddad, not my clockmaking granddad, but the other one in Spain in about 1974, I think. Right, let's have a look. Good. This is perfect, believe it or not, because when we look now, we can see it's not working, but you can't really see that, but it's actually jamming on the corner. So we know with the next removal of material is going to result in the thing working. Now, of course, what we don't know is which of these teeth it is that we're actually working with. Yeah, that's perfect. We can see that, but it's actually jamming on the corner. So, you know, the thing is about drop is that you need drop. Clock doesn't work if you don't have any, or this kind of escapement doesn't work if you don't have any. Now, of course, steady pins here would help things because we wouldn't have to put both these screws in each time. But anyway, so we're going to take off a bit more material, and then I think we'll be there and we'll be done. So just in kind of summary, getting ahead of myself, what I would say was, I don't know where this came from, but somebody at some point said, stone out or polish out wear from pallets. And I would say, well, obviously, I'm not going to say don't do that, but I would say before you do it, what are you doing? Because of course, that process is a process of effectively accelerated wear. If you get to that point where you need to reface pallets, I would say reface rather than bending the pallet frame, because as much as this is quite an interventive process, at least, move my camera so you can see, at least to the best of our knowledge, we're kind of retaining the frame of the shape of the pallet frame. Now I'm trying to avoid damaging the frame underneath with this diamond file thing. And the good, well, I don't know if it's a good thing or not, but with us using this material that we now know is incredibly hard, I suppose that might actually cause a problem, but we know that this probably won't have to be done for decades, I suppose. So I'm just going to do it a bit more than I normally I put it back and try it, put it back and try it, but I want to show this thing the way to go home today. So yeah, back to the Easy Lap diamond homes. They're a brilliant shape. I should have just bought the ones, either diamond files or the ones that are like backed by metal, so they're much more sort of robust. But I can see that if you're out in the field and you want to sharpen a knife, or as they say on the packet, a fish hook, then they're incredibly useful.
Jeremy said we got some stiffer ones from Art Bureau Trade.
Oh, okay.
In Leicester.
All right. Are they the ones that are retailed by Eternal Tools? Because I know they do a lot of diamond stuff, don't they? So Jeremy, is that in the live chat? Oh, people can see it then, great. Thank you, Jeremy, for that. So we've got a little mark there on our pallet. It's very shallow, if you can see it in the light. So I would probably stone that out, but frankly, it's out of the path of the skate wheel anyway. So this may be it. Last week with the other clock, whoops, I'd gotten organized with a piece of wood that I just pushed in and twisted a bit instead of having to put the screws in every time. But that clock has now been finished, so and we still need some more. Well, apologies for this, taking a bit longer than I thought. If you want to bear with me, I'm going to stick it out until it's done. As sometimes in the museum world, we do these kind of public demonstrations of clockmaking, and of course, what people say is quite understandably, they say, "Gosh, you must be really patient to do this job." To which my answer is, I am the least patient person in the world. However, it's the only way to get it done. So I mustn't get, all right, okay. I was worried that I was beginning to file down onto the pallet frame, the original frame, but we're not. We're about 0.1, 0.15 maybe of a millimeter off that, which doesn't sound like a lot, but it's enough. So you can see the diamond hones getting quite burnished, but according to the manufacturer, they're still sharp. So put it on the inside there against the old pallet frame, knowing that that's where I don't want to cut, and then just tilt the tool around a little bit. Right. More stoning or honing or whatever it's called. And incredibly, the thing hasn't fallen off yet. So miracle. Obviously, in retrospect, what I should have done is to have heated it up again and just slid it back quarter of a millimeter or something. But anyway, there you go, I didn't. And I suppose what this does, if you've not done this thing before, is it gives you some kind of idea of how long it takes. And if you're working commercially, of course, then this is something that your client pays for. And it gives you an idea of how much this would cost to kind of dial into the job. I suppose if you had a diamond wheel, you'd maybe use that very, very carefully, which of course would speed it up enormously. But the problem with that is there's a risk of obviously damaging the pallet frame, and also a risk of heating up the solder and it dropping off. So this is probably a good a way as any, albeit slightly taking a long time. Let's call it meditative, shall we? Of course, what I could have done is I also could have bought the coarse version of this thing, but I didn't. I bought medium. Fine and extra fine. Right, we're getting very, very close to the pallet frame now, so we must be about there, unless I've done something completely crazy. Super fine. There. Thought I'd lost it. Actually, you can see that on the picture, but it's not quite square, so I'm just going to square it up. Well, not perfect square, so I'll go back to that later, but let's have another look. So don't forget, if you want more clocks torture like this, then join us on Thursday night, where we've got a lovely rusty early 19th century long case clock, which we will be de-rusting a little bit and cleaning on Thursday, and dealing with the controversial subject not of whether we re-tap the thread on the pendulum rod, or how we're going to deal with that. Again, like this, the difference, I suppose, between practice and being a competent or being a practitioner, as in the kind of mechanical process, is sort of what you do with the decision-making process. Right, so there's our rogue tooth. Let's see if we can encourage it past that. Good, really pleased with that. But we've got at least one rogue tooth, and I'm going to leave it there because we're already 20 minutes over. So it's ticking really, really delighted with that. Now that could be a few things there. We haven't quite investigated it enough yet. It could be that the wheel, we know that it's not perfectly concentrically mounted, so do we re-collet it? It could be ovalized, it could be these rogue teeth, or is that it? Yeah, it's out of round, or eccentric, or odd teeth. Or probably, it's 200-year-old clock, probably some combination of that. Now you can see there's a little bit more, I wish I could get it past that tooth. Oh, there we are, a bit of brute force. So that tooth, yeah, there's more than one. So that's for another week now. But let's just move the back cop down as far as it'll go, just to minimize external drop. And go back. Yeah, it's quite a few teeth it's hanging up on. But where it doesn't hang up, it's fine. We've got plenty drop. So we need to start having a look at our escape wheel. So I think that's quite a useful thing. This clock is one that we just work on. So I think we can go back to that. Happy with the process there. Our new pallet face is hard. We polished it up with that stone. On many or most of the teeth, we've got a good amount of internal drop, but we know that on some teeth, we've got no internal drop. So there's a problem if you think of it that way. I don't actually think of it as a problem with the escape wheel. So it won't be next week, I don't think, because we promised we'd do the repivoting thing. So it might be the week after, but we'll start looking at this escape wheel. We'll get it in the lathe so we can look at the amount of eccentricity and go through options, because options are critically important when it comes to practice. So massive thank you to everybody who stuck it out for this extra 22 minutes now. A big thank you as always to Team Open Clock Club here dealing with the live chat. And if we don't see you on Thursday for the live stream, we might see you in the week for on Facebook, where we've got a few people who are really brilliant at helping out there. So big thank you to you guys. And if not, hopefully we'll see you next Saturday when we'll be looking at making a pivot drill and repivoting a wheel for a pivot that I broke off. So great. Thank you very much, and see you again.